When something breaks, the first question most developers ask is what ran. The question feels logical because you saw code execute. But execution is the part that is already gone. If you chase what ran, you end up staring at smoke and calling it evidence. The better question is what changed? Because the next line does not react to what ran. It reacts to what exists now in memory. If you debug by execution alone, you are always late. You are investigating ghosts instead of causes. And that is why the same bugs keep surprising you. Execution is temporary. A line runs, finishes, and disappears. The stack frame is created and then destroyed. Nothing about that execution survives. What survives is state. Fields, flags, counters, collections, and values remain exactly as they were left. That persistence is what allows the future to behave differently from the past. If you focus on execution, you focus on the only part of the program that cannot influence what happens next. If you focus on state, you're looking at the only thing the future can read. That is the pivot this video is asking you to make. Humans are wired to notice motion, not mutation. We notice verbs. Login, process, update, save. When something runs, it feels like progress. But programs do not advance because something ran. They advance because something changed. This mismatch creates a blind spot. You remember that loud call that executed, and you forget the quiet assignment that altered reality. Over time, this trains you to investigate the wrong places. You chase motion instead of effect. Until you correct this bias, object-oriented code will always feel harder than it actually is. This is the first failure pattern, action bias. A call like this looks important because it has a strong verb. It feels like behavior. But many methods are wrappers, routers, validators, or loggers. They execute. They consume time, and they feel central. Yet they may not change state at all. When you chase them, you waste attention and miss the real mutation. The fix is mechanical. Pair every suspicious call with a before and after snapshot. Ask whether any field, collection, or external output changed. If not, treat the call as narration. Every program already behaves like a state machine, whether you acknowledge it or not. There is always a current state, and every meaningful operation transitions the system to a new one. Ignoring that does not make the program simpler. It just makes the transitions invisible. When behavior surprises you, it is always because a transition happened that you did not count on. Once you accept that programs are state machines, debugging is easy. It becomes like bookkeeping. This is the second failure pattern, state amnesia. The condition, it did not invent behavior. It read history. The value existed long before this line ran. You did not forget the code. You forgot the state that code created earlier. This is why bugs often feel like they appear out of nowhere. They do not. You simply stop tracking what the program remembered. The computer remembered. You forgot. Nothing about this code became smarter or dumber. It just became earlier or later. Order decides which state is visible when a read happens. If you treat order as cosmetic, you will miss entire classes of bugs. Execution order is behavior. It defines reality at the moment of evaluation. Hidden state is where bugs thrive. Field, globals, cached values, and captured variables. They mutate quietly. If you cannot see the mutation, you cannot predict behavior. Cleverness hides state. Visibility controls it. The more hidden state your program has, that state will surprise you. This feels safe because nothing persists. No memory to track, no history to remember. The result depends only on the inputs. This is not about style or ideology. It is about cognitive load. Less state means fewer surprises. More state demands more discipline. If you cannot say what changed, you did not understand the code. Everything else is decoration. Before tells you context. After tells you consequence. Difference tells you behavior. This model scales from one method to entire systems. Understanding is not tracing after the fact. It is knowing the outcome before execution. If you cannot predict the final state here, the fix is not more tracing. It is better state tracking. When you stop asking what ran and start asking what changed, debugging becomes boring in the best way. The future does not know which method executed. It cannot see call stacks or intentions. It only sees the state that exists right now. That is why state is the only thing that truly matters. Methods come and go. Execution vanishes. Memory persists. Once you accept that, behavior stops feeling out of place and starts feeling mechanical. If code keeps surprising you, it is not because object-oriented programming is magical. It is because you are tracking the wrong thing. Once you make that shift, bugs are easy to track. They stop feeling random. They become predictable. That is when you actually gain control over your programs instead of reacting to them.